Okay, welcome to part three of lesson four. Now we're going to look at Adam Smith's labor theory of value. Adam Smith, often called the father of modern economics, introduced the labor theory of value, LTV, in The Wealth of Nations. The theory explains how commodities derive exchange value, distinguishing between primitive, pre-capitalist, and advanced, capitalist societies. Smith also separated value in use, utility, from value in exchange, market price, emphasizing that in competitive markets, prices gravitate toward production cost, with labor as the key input. Human effort, rather than divine or arbitrary factors, becomes central to value creation. In primitive societies where individuals produced directly without employers or landowners, the value of a commodity reflected the labor embodied in its production. For example, if hunting a beaver took twice as long as hunting a deer, two deer would be exchanged for one beaver. Smith wrote, the value of any commodity is equal to the quantity of labor which enables him to purchase or command. Labor, therefore, is the real measure of the exchangeable value of all commodities. Here, labor is both the source and measure of value because the entire product belongs to the laborer. In primitive societies, according to Smith, the exchange value of commodity is primarily determined by what? In advanced capitalist societies, Smith noted that the value diverged from pure labor input due to the presence of capital landowners. The whole product of labor rarely belongs entirely to the worker. Wages, profits, and rents all claim portions. Thus, market prices reflect the labor a commodity can command in exchange rather than the labor directly embodied in it. In modern terms, Smith effectively moderated a strict labor theory of value, recognizing that supply, demand, and institutions influence prices. David Ricardo and Thomas Malthus extended Smith's insights. Ricardo emphasized that value derives not only from direct labor, but also labor embedded in tools and materials, providing a foundation for analyzing comparative advantage in trade. Classical economists use labor theory of value to explain stable long-term prices, profits from surplus labor, and the benefits of productive work over speculation. Karl Marx in Capital 1867 adopted and extended Smith's labor theory of value as a critique of capitalism. He distinguished between use value and exchange value, asserting that the latter is determined by socially necessary labor time, the average labor required under normal production conditions. Marx argued that workers produce more value than they receive in wages. The surplus is appropriated by capitalists as profit, leading to exploitation. His labor theory of value explained class struggle, alienation, and the tendency for profits to fall over time. Marx envisioned a system where labor's full value returns to workers, eliminating exploitation. According to Marx, socially necessary labor time is. Economists from the yet to emerge Austrian school, such as Menger, von Bauwerk, and Mises, rejected labor theory of value in favor of a subjective theory of value. They argued that value arises from individual preferences and marginal utility, not labor required to produce a good. For example, a pearl's worth depends on how much people desire it, not the effort spent polishing it after harvesting it. Similarly, a painting has value because of its scarcity and appeal, not the hours spent creating it. Profits in this view reward entrepreneurship and innovation rather than labor exploitation. Play and pause the following video to help you solve your version of this problem. Compute all numerical values using unrounded numerical inputs when entering your answers into answer boxes, round to 3 decimal places. Mathematical modeling of labor theory of value. Imagine Adam Smith strolling through the bustling market square on his way to lecture at the university. He pauses often, notebook in hand, recording the voices of merchants calling out their prices, buyers haggling over bread, cloth, and pins, and the quantities laid out on tables. Week after week, his notes capture a clear pattern. When prices are high, stalls fill with goods. When prices sink too low, baskets remain half empty or absent altogether. The data observations he carefully jotted down in his imagined notebook on the weekly trade in pins are transcribed from his notebook into the HTML table below. preserving the record of how the average cost of producing goods, quantities, and market price interacted in the marketplace. So here's week 1 to 10. Quantities sellers bring to market, bundles of pins, market price of effectual demand. This is the price along the demand curve. Natural price, or the cost of producing the good, the price along the supply curve. Notice as the quantity increases, the price along the demand curve falls, and the price along the supply curve rises. In his account, the supply of pins responds positively to price. During the first weeks, when only a few bundles are offered, scarcity drives price up to around 111.4 pence per bundle. At such prices, even a small amount of labor is well rewarded. So some pin makers rush to enter the market. As more sellers participate and greater quantities are offered, prices fall. By week 9, 140 bundles are available and sell for about 69.8 pence. Smith notes that the average cost of producing pins rises with output from 25.6 to 46.4 pence per bundle in week 9 to cover workers, materials, and rent. Since expanding production makes labor and resources scarcer and more costly. The narrowing gap between the market price, what we now call the price on the demand curve, and the natural price, the price on the supply curve, means that sellers earn less surplus than they did when goods were scarce. He imagines how merchants decide what to bring to the market next week. Observing the steady decline in prices as quantities rise, he envisions them producing 150 bundles for week 10. When they display this quantity in their stalls, the market price adjusts to 64.6 pence. Not because production costs increase, but because the quantity offered is on display in the stalls of the market. Buyers and sellers meet at a price somewhere between what consumers are willing to pay and what producers need to cover their expenses. As Smith enters his office, he reflects on a broader lesson. The labor and effort required to bring goods to market form the foundation of their value. He recalls a simple example. If hunting a beaver takes twice as many hours as hunting a deer, a beaver should exchange for roughly 2 deer. Similarly, pins, bread, and cloth in the market square carry values tied to the labor and activities needed to produce them. As more pins are supplied, additional labor and raw materials must be hired. But as these inputs become scarcer, their costs rise, increasing overall production expense. High prices attract more sellers, yet rising costs limit how much supply can expand. Meanwhile, buyers resist high prices and purchase more only as prices fall. Together, these opposing forces move the market price, the price along the demand curve, toward the natural price, the cost of production, a balance where labor is fairly compensated and consumer wants are met. By examining how market prices and production costs influence the filling and emptying of stalls in Smith's Imagine Notebook, we can use modern tools like Excel and Desmos.com to explore concepts of supply, demand, and equilibrium. First, copy the numbers in the columns for quantity brought to market and natural price into a table in row 1 of Desmos.com, and the numbers in columns for quantity brought to market and market price to a table in row 2 of the same Desmos.com model. To generate the equations and draw lines through the points, click the icons in the top left of each Desmos row. This process will illustrate graphically what Smith could only observe in his mind. When only a few bundles are available, prices are high. As more enter the market, prices decline. Adam Smith could not have imagined graphing or estimating an equation for the relationship he observed between the quantity brought to market and the natural price, as shown in row 1. I'm going to fill this table in with data, X1 being the quantity sellers bring to market, and Y1 being the market price of effectual demand. So this is 60, 111.4. I'm going to put the video on pause. When I have these two columns filled in, I'll restart the video. Okay, I got the quantity sellers brought to market in column X1 And I got the market price of effectual demand in column 2. To make sure I entered the information in correctly, I'm going to click on this icon here, 4 dots in a line. Notice my correlation is -1 and my coefficient determination is 1. That means these points are on a single line. None of the points are off the line. If these are not 1 and -1, then I have a situation where one of the numbers or multiple numbers are not correct. So you just need to go through and double check that they are correct. Now I'm going to do the same thing down here for quantity sellers bring to market and the natural price or the cost of producing the good. So I'm going to click row 2 plus table. I'm going to enter these quantities and then this last column of prices. When I'm done filling in the table, I'll restart the video. Okay, so I've entered the other data in. This is the quantity sellers bring to market, and this is the natural price or the cost of producing the good. Now I'm going to click on this icon here to see if I did it correctly. If I did it incorrectly, this would not be equal to 1, and this would not be equal to 1. So if you have something other than 1 and 1 here, make sure these numbers match up with those numbers, and these numbers match up with those numbers in your version of the problem. The purple line here is the supply curve, and the black line is the demand curve. So as shown in row 1 of the Desmos.com worksheet, Desmos uses simple regression analysis to estimate this equation right here. Today we refer to this relationship as supply. So I'm going to type in the supply equation. The first column is quantities, so this right here is quantity, and the second column is Y, so this is price. I got this backwards. I want to move this one up. Row 1 is quantity brought to market and the natural price. And the natural price is this column here. So over here, I've moved the row from here up to there. So the natural price and the quantity sellers bring to market are right here. The quantity sellers bring to market and the market price of effectual demand, they're down here. So this purple line, it slopes upward and it's got positive slope because this is a positive 0.26x and the intercept is 10. So this right here is the supply equation. The intercept is 10. The slope is 0.26. X, remember, is Q. These are quantities here in the X column. And the slope, I'll just copy it, 0.26. And I'll press enter. And I'll let you answer this question here. On any of these drop-down menu questions, pick what you think is the best answer. If you get it right, cool. If you get it wrong, come to my Zoom office hours so we can discuss it to make sure you get it correct. Now in row 2, we have quantity brought to market and the market price, the maximum amount buyers are willing to pay. So that's row 2 down here. This is the maximum prices buyers are willing to pay at these quantities. And notice that the slope is negative 0.52. So we're talking about the demand curve down here, right? So this is 0.52. I don't have to type a negative because this right here is subtraction. And then the intercept is whatever this is. I can't really read that. I think it's 142.6, but I'll copy it and paste it so I don't get it wrong. Okay, so I have my demand equation and I got my supply equation. Again, pick what you think is the best answer. If you get it right, continue on. If you get it wrong, put it aside. And then to make sure you get it right, come to my Zoom office hours. Adam Smith's concept of equilibrium describes a long run state where the market price, the price along the demand curve, gravitates toward the natural price. The natural price is the price along this supply curve. The market price and the natural price are moving closer and closer and closer to each other over time. This equilibrium, or what Smith called natural repose, occurs when effectual demand meets supply. If the trends Smith observed in his imagined notebook had continued, this point would arrive after week 10. Here's week 10. The prices are far apart in week 1. These get closer and closer and closer to each other, and they're going to meet sometime after week 10 because these are falling and these are rising. So eventually the two are going to meet after week 10. And that's going to happen when the quantity brought to market equals what? Well, to figure that out, we just got to click on this point right here. This is the quantity and this is the price. Because the first column, remember, is quantity. The first number is the X. The second column, P, is the Y value. So this is the quantity, 170. We call that the market equilibrium quantity. At this price of 54.2 pence per bundle, the quantity that is supplied or brought to market is going to equal the quantity that people want to buy. When the natural price, the price determined by supply, equals the market price, the price determined by demand, or effectual demand, as Smith would say, we call that value the equilibrium price. Add it the quantity that is brought to market satisfies effectual demand. And production cost, as Smith would put it, covers the laborer's full toil, a base wage of 10 pence per bundle, plus 0.26 pence more per added bundle as hands grow scarce and efforts weary. No excess profit attract new sellers, nor do losses drive them out as prices align with cost. Smith also observed that producing more pins requires additional labor and raw materials, which become scarcer and therefore more costly. And so those two, if you get them marked right, cool. If you get them marked wrong, come to my Zoom office hours and we'll make sure that you get them right. Adam Smith emphasized that supply expands with price because more labor and resources must be employed as output grows. Yet in practice, entrepreneurs face a different constraint. They must commit to a quantity in advance of the market. By week 9, producers in the pin trade observed the market price changing from 111.4 pence per bundle of pins in week 1 to 64.6 in week 10. And the average cost of producing bundles of pins rising from 25.6 pence per bundle in week 1 to 49 in week 10. On this basis, they decide how many bundles to produce in week 10 for sale in week 11. At a market price, they expect it to be what? Quantities are increasing by 10. I'm going to type 160 here. And then down here, I'm going to do the same thing. I'm going to press enter and type 160 there, right? And then we got to estimate what the average cost will be and what the price people are willing to pay, the maximum price people are willing to pay. So to estimate those two things, what I'm going to do is I'm going to click on this. I'm going to click plus and expression. So I'm going to put a row below my first table. I'm going to copy this expression here. This is the average cost line in Adam Smith's view. I'm going to change this to 160. So if in week 11, they supply 160 units of output, they expect the average cost of producing the 160 to be 51.6. And notice what happens over here. I get a dot on this purple supply curve, the Smithian supply curve, which is actually average cost. There's no dot here yet because I haven't calculated it yet. So down below this table, I'm going to copy this expression to the right of the equal sign. I'm going to copy that. I'm going to put it in the row right below it. I'm going to change the X to 160 times 160. And notice what happens. If producers supply 160 units of output in week 11, they expect the maximum price consumers are willing to pay is 59.4. So I'm going to type 59.4 there. And when I do that, notice what happens. I get this dot that corresponds to week 11. In week 11, they expect the maximum price to be 59.4. Entrepreneurs are seeing these trends. If they collectively supply 160, given what they observed in the past, they expect to sell the 160 for 59.4. The quantity of pins they decide to produce for week 11 is fixed at 160. This decision involves hiring the appropriate number of laborers, acquiring the needed quantities of raw material, and this is all happening before they bring those bundles of pins to market, and continue to pay for tools, buildings, and land. All these inputs are actually sunk once the bundles are manufactured by the end of week 10. They've looked at the trends and they think, well, we can produce 160 bundles for sale in week 11. On the day of exchange in week 11, supply is fixed at the amount of product that is brought to market, 160. The supply is what? Well, supply would be then a vertical line. A vertical line is perfectly inelastic. So what I'm going to do down here is I'm going to type X for quantity 160. And then I'm going to turn off the purple line. I'll leave the green dots here because these are our average variable cost. So supply is really a vertical line because the decisions on how much to produce was made and that production was done before that product was taken to market. So on the day that product's taken to market, it's a fixed quantity. And the entrepreneurs are hoping, they're hoping that they cover their cost. And they happen to cover their cost because the average cost are what? This green, the height of this green dot. And this vertical supply curve, this, I guess you could call it Austrian economic supply curve. It's a vertical line. It crosses demand at the point 160 and 59.4. So 59.4 pence per bundle. Now, why is supply perfectly inelastic on the day of exchange? I'll let you pick the correct answer here. We've already talked about it. If the last column of the table above represents the average cost of making this quantity of pins, then the supplier's average cost are equal to what? That's the height of this dot, this green dot. And we already calculated that. That's 51.6. These values are rising, and the last one we actually calculated was 51.6. These costs do not determine the price buyers pay. Rather, they determine whether sellers can continue in business and supply product the following week. Profit per bundle equals what? The average cost is 51.6. The price the firms are getting is 59.4. The difference is the unit profit, which is 7.8. When profits are positive, sellers are lured, just as Adam Smith said they would be, they're lured into the market. Today, if profits, we would say, if profits are above normal, that draws firms into a market and supply increases, which pull prices down. When losses occur, sellers are driven out. Adam Smith made that point, and we make that point today. What do profits and losses signal in this entrepreneur model? Again, I'll let you figure that out, right? If you get it right, cool. If you get it wrong, come to my Zoom office hours. Thus, profits and losses act as market signals. Efficient producers recover their cost and more, while inefficient ones struggle. Persistent losers must either innovate, for example, refine the division of labor, or exit the market entirely, allowing resources to flow toward more capable competitors. In this sense, the entrepreneur's risk-taking role, absent from Smith's own model, is crucial for understanding how short-run supply behaves, a perspective that only emerged much later with the so-called marginal revolution. And then I'll let you figure out what this is.